Hello guys, I'm Sandip. I'm a physics faculty at IIT-JEE, and today we are going to start a new chapter which deals with the winds, storms, and cyclones. Right, so that is our basic chapter. So let's see winds, storms, and cyclones. All in all this in this chapter, we are going to study that wind. Right, normally we say air. Air is very thin. Right, can air apply the force? Right? Mm, Yes, it can apply the force. How it applies the force? Right? It is in the form of wind. We can say very simple. Then you must have heard the cyclone, right? Even recently in 2019, that cyclone which is named as Nisarga cyclone came to India, right, towards the sea face of our Mumbai or Gujarat, like those, right? Those states, right? Even in case of Odisha, if you know Odisha in the north, right, near the Kolkata, there is a very big possibility that cyclones will hit, right? In many years, many cyclones hit that Odisha, right? Remember the one no, place called Puri, right? In exams, we are going to get that question that in Puri, that cyclones do hit Puri many times. Puri is in based in Odisha, we can say. Okay, so these are the cyclones. Cyclones means what? Right? So you can see that cyclones do a lot of damage on the property of the homes, houses. Many people becomes homeless there, right? And those people who are living near the sea, near the ocean, we can say, right? So those are the states, right? You can say, as I told you, Puri in Odisha, those states, Kerala also, you can see, those states can get affected by these cyclones a lot. Okay, so so this is about the cyclone. Then let's talk about the winds. As I was saying, that wind also have some energy. Yes, air in the form of wind can apply a lot of force, and that's why that whole damage thing happens, right? So you can imagine now what a bigger force is that, very big. Okay. Also, how these winds occur, how they get generated, right? As we are saying that winds are very big now, then how those winds actually get generated. We are going to study this whole thing here. Okay. Sure. So let's see what we are going to cover in this session. First thing first, what is wind? And pressure exerted by air, or you can say force exerted by air. And what happens if we heat the air, right? And how the wind current is generated. Current means not our electrical current, right? Wind current means flow of current, normal. Even for water also, when the water flows through the river, right? What we say, water current is flowing. That doesn't mean that current is there. Right? It's not current, which we used in the electrical circuits, right? Amperes current. That's not that. Wind current means that yes, wind is flowing, and how that wind current is generated. Okay, so we are going to see over all these topics in this session. Okay, so first of all, let's see what is wind. So simple. When the air is in motion, can we say it is wind? Yes. Okay. So who is creating that wind? That's we are going to see, right? Okay. How the water current gets generated. So simple thing we can say. First of all, wind is simply the air in motion. Okay. So wind is caused by the way sun warms the earth. Right? Here we have seen the third point is what is the third point? Effect of heat on air. So if the air becomes hot, then we are getting some kind of wind, right? How we are getting that? So let's see. So wind is caused by the way the sun warms the earth. Some parts of the earth get direct sun rays that makes them warmer. Other parts of the earth get indirect rays and those are cooler. So obviously we know that our earth is like this. Recall, right? This part is called as circle. Let's say if you complete the circle, this part is called as what? This is called as equator. Can I say the rays which are coming from the sun, let's say sun is very big, right? They will hit the equator first. Earth is rotating that. So every point in one in day is going to get a lot of heat, right? Before the other parts. You can see the normal, this is called at what? This is our North Pole, right? And what is this? This is our South Pole. So what I can say in this case, in comparison with the North and South Pole, this equator part is closer to sun, and therefore it get a lot of heat and direct heat. We can say this north part could get some indirect rays. Right? Indirect rays means obviously some rays will be blocked when they are coming, because you can also consider that atmosphere is here, right? So atmosphere is also going to block some of the rays. So that north pole is going to get indirect rays, but some part are going to get direct sun rays. So sun, what is the job of sun or the rays? Sun rays, they are heating. They can have the heating effect, right? We can use those effect in the solar panels, etc., etc. So yes, they are heating the surfaces. So can I say this equator or the points or the parts or the places which are on the equator are getting hotter compared to north and south? We already know that South Pole, North Pole have the islands, right, made up of ice, right? I think the Antarctica is in the toward the south, right? There we cannot even go because the temperature is very, very less, right? That because of the ice, because sun rays don't go there directly. Therefore, it becomes very icy material, and therefore the temperature is also very low there. Okay, so yes, so what we can say, obviously different places have the different temperature, and because of some heating effect, that wind will get generated. How, that we will see ahead, right? Okay. So this is about the wind. Now let's talk a little bit about the pressure exerted by air. Okay? So you must have seen this air pressure in one of the chapter of the courses, right? There was some pressure in fluids there, right? Actually, you must have seen this concept also. Okay? So whenever there is an object, we let's say in the water also. Water is also fluid and air is also fluid, right? Let's take one example of the water, right? Suppose in the ocean, if there is object, a fish or anything, right? What will happen? That water applies the pressure on that object. Water applies the pressure on the object. Therefore, we can say that object gets force, right? Simple. So pressure increases as you go inside the ocean, inside the water, that we know. Okay. So now remember one thing. Nowadays many scientists or many countries are trying to go to the Mars, right? Even we have done a lot of space exploration, right? We have done a lot of missions, as a Mars mission, Moon mission, etc., in the space. But remember, we haven't done any study inside the ocean. Ocean is also, it has very depth, right? But we are not doing a lot of study inside the ocean. But space, yes, we want a space. Why it is like that? Because to do study inside the ocean is going to be very difficult. Why? Because as you go into the depth of the ocean, what is going to happen? Right? That pressure is going to be very, very, very high. So even to go inside the water, you require a lot of force. And to do some research there, it is going to be very difficult. Right? Therefore, human do prefer the space exploration than ocean exploration, we can say. Right? So this is the pressure exerted by water. Now let's talk about the pressure exerted by air. Right? So air is also a fluid, as that of water, but obviously air pressure will be less than that of water pressure. Now, even consider this is the sea, this is the ocean, let's say, right? And our Earth is not flat, right? It has some mountain parts like this. So consider this is our top of the mountain, right? This is called as sea level. Let's say this is sea level, right? So when we go, this is here we have the 1 atmospheric pressure, 1 atmospheric pressure. So as we go above and above the sea level, pressure actually decreases, right? In one of the chapter, you must have seen some diagram like this. This is the air column actually. So this is the earth and this is the air column. This is called as air column. You must have seen this diagram somewhere, right? So this air column actually exerts 1 atmospheric pressure at sea level. Sea level means this level, right? Okay. So another thing, how to measure this pressure, sea level or etc. So for that we use the mercury barometer like this, right? So what it does, so there is a very small instrument of the mercury. Let's say this is the container and mercury is kept in that, and one tube like a test tube, you can say, right? But it need to be at least, let's say, 1 meter. The height should be 1 meter, right? Take this instrument here, and you will observe that this mercury rises here. Why it rises? Because air also applies some pressure or force, we can say. So you can see here, this is the atmospheric pressure exerted by what? Exerted by air. On which part? On mercury. And therefore this mercury rises up here. Right? So at sea level, you can say it rises up to 76 centimeter. So at the sea level, we can say there is 1 atmospheric pressure or 76 center of Hg. Hg means mercury of pressure, right? Or 1 into 0.13 into 10 raised to 5 Pascal pressure. Pascal is your important unit, that is SI unit, you can say. So normally we can measure the pressure in these 3 terms: atmospheric or this height of the mercury column, right? Mercury column means in this mercury barometer. This is called as barometer, right? Or in Pascal. So if you go, if you consider take this instrument at the top like this, it will not rise up to 76 centimeter. It will be lesser, right? It could be 72, 70 like that, right? So pressure at the top will be less than that of sea level, you can say. Okay. So now we know that air exerts the pressure. Okay. Good. So now you can do this small activity. What you can do in this case, take one tin can, right? Tin can means most probably you can find it in our home as oil can, right? Cooking oil, we have the cooking oil, right? That cooking oil normally have the tin can, right? Then what to do in that case? Put some water into that and put the lid, then put it on the gas or burner, we can say, right? Okay, so if you obviously if you want to perform this experiment or activity, please take the guidance from the parents, right? Don't do that alone. So there is a fire, so that water in the can is going to go heat up, right? After that, it will also generate some steam. So can I say steam is inside that can? Yes, that's good. So after burning that, keep it somewhere in wash basin or somewhere and put some cold water onto that on this can, right? What is going to happen? You can see in this diagram. This will get distorted like this. The steam can, which was very good looking at initially, right? It is going to get distorted like that. Right? Can I say it is getting compressed? Why it is happening? This is because the pressure of the air, right? How it happened? Let's see. So what we say, that water was inside. So when we heat that, then that water, most of the water got converted into steam. Now, as the lid is closed, therefore, what is happening? There is a lot of steam inside, and or do one thing, we can also close the lid after the steam got there, right? So steam is there. So what is going to happen? That steam has some pressure. That pressure means what? That steam is actually pushing the walls of this container away like this, right? So I can say it is pushing like this. They have pressure, right? So we can say pressure inside. This is the pressure of the air or steam. We can say inside the can, inside the can. Okay, and here pressure is outside. We can say this is our atmospheric pressure, right? We know that one. Okay, so pressure inside is enough to push that can outward. Now, what happens when you put the cold water on this can which has the steam inside? Right? What will happen when you put the cold water? Some of the steam inside that can, we can say, is going to get converted into water. We know, right? Steam is if you cool the steam, it is going to get converted into water. So what will happen? Now this can will have very less steam. So if very less steam, then what we can say, it will not be able to apply that much of force on this walls of the can. But this atmospheric pressure is now applying the force from outside. So what will happen? That can will get compressed. Okay, so this is the case of the pressure and how it actually applies the forces. Very small experiment. Okay. Then now let's talk about the effect of heat on air. Right. So remember, warm air travels towards the region of lower pressure. Right. We have at the start we studied that some places on the earth are getting more heat than the other places. Right. Why it is happening? Because that sun rays are hitting directly to them, right? And some places there are indirect rays. Okay? Now, just consider the effect of heat on air. So, what happens if you heat the, let's say, air? Let's take one very small activity like this. So here, what you can do, take two paper bags like this. So these are paper bags, identical, both are same weight, same everything. Right? Now, take one small stick, right, and attach these paper bags like here, like this. Okay. After that, use the burner or candle. You can normally use the candle also, right? Candle is also safe also. Use this candle and place it here. What will happen? This air, which is above the candle, or we can say near to the our paper bag, will get warm, more hot than this air, right? So this will be, let's say, cool air. This is warm air. So what you are going to observe here is that these bags, one bag will go upward like this, and other will come down. Why this is happening? Here it is a warm air here. So remember, warm air is a lighter than the cold air. Right? What I can say, warm air is lighter than that of cold air. So therefore, that warm air is going to go upward as it is lighter. Therefore, that bag will go upward. Because this is also a small activity you can try at home. Okay. Also, this will give, you must have studied somewhere sea breezes and land breezes, right? So what happens? Consider if this is the ocean, right, and this is our land. So water and land are there. Okay, so because of the sun, remember, land gets heat faster than water. What I'm saying, land gets heat faster than water. So what is going to happen if this land is very hot compared to the this water? What will happen? Air which is above, let's say air particles which are above the ground, will become warm, And what about the particles, air particles on the ocean? They will be cool, right? So what happens? We know warm air goes upward. Why? Because they are lighter. So what will happen? This warm air will go upward. This cool air will go to take their places, right? And warm world, then we can say warm air will go like this. So what we are getting here? Something which look like the anti-clockwise current. Current is, again I repeat, there is a wind current, right? So wind current can get generated. Why? Because of that heating effect. Okay, good. Now in the night time, when the moon is there, right? In the night time, we know that part. Now, as land gets heat faster, right? It becomes hot faster. Similarly, it also becomes cooler faster. Right? So now this air becomes cool. Why? Because it loses the heat fast also. It gets the heat fast and loses the heat also fast. Right? So if this is cool, water will take some time to get cool. Right? Therefore, air above the water becomes now warm as compared to your air on the land. Okay, so what will happen now? This warm air is going to go upward. This cool air is going to take its place. So here you can see the uh, again the wind current, right, in clockwise direction. You can see these are called as land breezes and sea breezes. Okay, so this is how we can get the wind. So we understood now the concept that how we are actually getting the wind due to the heat effect. Okay, good. So now let's see. So effect of heat we are seeing on air. So we already know that warm air travels toward the region of lower pressure. Right. So you can see, yeah. So this is a warm air which will have the low pressure, and cool air travels towards the warmer air. We can say. Right. So simple. Even in this case, also cool air was traveling towards the warmer region, and warm air is following going towards the cooler region, right? So warm air travels towards lower pressure or cool air, we can say. So this is how, this is nothing but our water current. Therefore, air moves like that. Very simple to understand, right? Okay. So this is the effect of heat on the air. Even you can consider the desert, right? Consider the Sahara Desert in our in India, right? So in desert, because of that land desert, that becomes very hot, and other part of the other places you can say which have a lot of greenery, right? They becomes cool. So air here is going to go from year to year, because we know that this warm air travels towards whom? Towards the cooler part, and cool air is going to travel through warmer part, right? So near the desert also we can see there are many storms, right? You must have heard in the desert there are big storms do come there, right? Right? Which actually takes the sand anywhere, because obviously that storms will have very high energy or very high pressure, we can say. Okay? So this is the effect of the heat on the air. Okay? Now, so now let's see how the heat is generated in this case. So what we can see here is, yes, as we already know that equatorial plane is going to get heat directly from the sun. And what about the other part, that is no polar part, you can see here, or this is your south region, Antarctica is there, right? Okay, these are cooler compared to the equator. So what is going to happen? We already know that if this has the more heat, then air above the equatorial places will be what? It will become very hot, right? Or warm air, we can say. Okay? So those warm air are going towards what? Towards the cooler region. We know that part too, right? So therefore, this currents, these are called as a heat current, right? Wind current or heat, not heat current, but wind current. Let's call them as heat current. So this air is trying to go away from the equator towards where? You can see towards the cooler region, right? And the cooler air, which is from North Pole, or you can even see the South Pole, they are trying to go towards what? Water region, right? And that is how we are going to get wind current there. Okay. Also, if you compare your earth and sea or land and sea, we know what is going to happen. No, daytime air from the sea goes towards the land like this, right? So that is going to happen. That wind, and if wind is very very fast, it has a lot of force, then it is going to destroy a lot of property, right? So that there will be a lot of loss. That is what we call as cyclones or big storms, right? Like that. So here also you can see, consider the India. India is here, right? Okay. So wind is going to affect these areas a lot. Coastal areas we can see. Here also you can see, right? We know this is our Mumbai, Delhi. Delhi is well inside, right? So Delhi don't have a lot of chances to get that cyclone effect, right? Gujarat is somewhere here. Kerala is coastal area. Then Odisha is here. So these parts are going to affect a lot. Even you can see due to this geometric thing here, right? It is this Odisha is actually is getting very affected by those cyclones. Okay. Okay. So this is how the actually wind is generated. Okay. Now you can also consider the example as we were talking about the pressure, and we know that air flows from where? Higher pressure to lower pressure. The same thing we can also use in let's say aeroplane. How the aeroplane wings are made up of, right? So here one thing we have to remember first, that if the velocity of air is high, pressure is low at that point. Pressure is low. Similarly, if I can say if the velocity of air is low, pressure will be high. So as I was talking about the aeroplane, so aeroplane looks something like this, right? It has some wings. Now those wings are actually going to do a lot of job for the aeroplanes. Okay. What happens? Those wings are designed such that we can say they are going through or swimming through the air. Let's say they are swimming through the air. So what will happen? That air is going to go coming from this side, right? So the design is such that, consider they could make the design something like this of that wing, right? So if this is the wing, what will happen? The air will go like this. So most of the air is going to go like this. So I can say the velocity of the air above the plane is very high compared to down. Okay. So what happens in that case? If the velocity at the plane is high, say the velocity is high, can I say pressure is less at the top? Yes. Velocity at the bottom is less compared to our velocity at the top. So pressure will be more. So if the pressure is more at the bottom and less at the top, what will happen? Right? There will be pressure difference, and that air is going to lift that aeroplane. Right? It's like that. So this is what happens because of the pressure and velocity. So remember one point here, that velocity of air pressure is high, or let's say velocity of air, not air pressure. If the velocity of air is high, pressure at that point will be very less. Okay. Then we can also relate this example to, let's say, in cyclotrons. What happens? In cyclotrons, this upper part of our homes, not our homes, but people who are staying there, right, is going to go up, right? It gets destroyed. Why it happens like that? Mostly for the hut, we can say, right? For the hut, those upper part will go away, burst away, we can say. Why is that happening? Because when the air is flowing like this, right? So can tell me velocity of the wind. That wind is very high, right? Wind means storm. We can say cyclone. So those have very high velocities. So if those have the high velocities, so at the top, can I say velocity becomes very high? So if the velocity is high, what we studied, that pressure will be low. Right? Those winds are not going inside the house. So what I can say, velocity is less inside the house, pressure will be high. So where is pressure high? At inside the house. It is low outside the house. Right? So what happens? The force is getting applied on this top portion of the house. Therefore, that lot of force is actually is the reason we can say that top of the house is going to blown away. Okay, so this is what happens in the storms or winds, right? So now, so this is the whole thing we can say of our this first session. So here we just have studied important things, that what is wind and how the wind current actually gets generated. That is due to, we can say, temperature difference, right? Heating effect or temperature difference. Therefore, we can get the wind generated there. Okay, and what to remember, that equatorial place gets the heat higher, or we can say more than the north and south poles. So they are trying to warm the air above the equatorial plane becomes warm, and that heat, hot wire, we can say, it is going to go everywhere. Okay, so that is how we get the wind current generated. Okay, so this is the basic thing of the wind and the pressure of the wind. We also have seen that how that pressure things behave, and now we also know that wherever there is a less velocity, pressure will be higher, and if the velocity is more, pressure will be lower. Okay, good. So in next session on this chapter, we are going to study about the cyclone and thunderstorms and storms, right? Okay, so before that, let's see these questions. Very small theory questions, simple theory questions are there, right? So first of all, leaves of the trees, banner, flags flutter when the wind is blowing. Why? Right? Very simple thing. Air exerts the pressure. Air occupies space, doesn't make any sense. Air is a mixture of gases, so what? Right? It is not going to be a reason of trees, banner, or flags. Air is colorless, so what happens, right? So only air exerts pressure is our answer. Now, let's consider the next question. When we blow over a paper strip, it goes upward as shown in the figure. Right? So, and why they are saying why it is happening. So, if you blow the airstrip means what? Take from your notebook, cut the very small portion of the paper, right? Like this. Cut the portion like this. This is, we can call this a paper strip. And now what this person is doing? He is blowing the air, keeping the strip closer to the mouth, and blow the air above. Right? Now what should happen, and what is happening in this case? Right? So if he is blowing the air like this, what we can say? The velocity of air becomes more. And we know what happens if the velocity becomes more, pressure decreases. So at the top portion, let's say this portion, velocity is more, pressure less. At the bottom point, you can say velocity is less, pressure is more. And we know what happens in this case, right? So that airstrip moves upward, we can say. It goes upward. Okay, so let's see which one is the correct option. First of all, blowing over the paper reduces the air pressure above the stream. Is it right? Above the pressure, we already said that yes, velocity increases, so pressure decreases. This is right. Second says blowing over the paper increases the air pressure above the stream. No, it decreases. We know that. None of this correct. And strip will not go upward at all. No, strip is anyway going upward, right? We can see here. This is also a small activity you can actually do at your home, right? Very easy activity. Just have to blow some air above the airstrip. Airstrip means this is the airstrip. Okay. So this again gives us why the if the velocity increases, pressure decreases. Okay. Good. Now, which of the following places is most likely to be affected by cyclone? Cyclone. Okay. I think I already told you at the answer at the start of the lecture only. Here also you can see in the diagram. Okay, so Mumbai. Where is Mumbai? Mumbai is here somewhere, right? Then Goa. Goa is just below the Mumbai. Then Porbandar. Porbandar is in Gujarat. Know that part. And Puri. Puri is in Odisha. Right? So somewhere here. Right? Okay. Now, as I told you already that this is the geometric shape near the Puri, which actually is responsible for creating those cyclones, right? Or big storms in the ocean, right? So yes, all those are the coastal areas. Here, I told you in 2019, there was a cyclone which is called as Nisarga cyclone, right? That just went passing nearby to the this Mumbai and Gujarat coastal, but it didn't do the lot of loss actually. That's good, right? Okay. So yes, these are affected, but this Odisha or Puri, we can say, because of this geographical shape, it has a lot of chances of hitting the cyclones. Okay, so that's why we can mark the option Puri here. And what about the middle places? As I said, Delhi or Madhya Pradesh, right? Or those places doesn't get a lot of affected by these cyclones, right? Because they are way away from the oceans. Okay. Good. Now, so this is the whole theory of our first session, which we talked about the winds, velocities, pressures, what are the forces applied by the air pressure, how the wind currents form, right? What are the heating effect, right? Also told you what activity you can do at home, right? So, but remember, whenever you are doing those activities, especially which includes the fire, take the supervision of the parents, right? So those are important things of the first session. Okay. So in next session, we are going to study about this, as I talked earlier also, that we are going to study about the thunderstorm or cyclones, how these cyclones actually happens in the ocean, right? Okay. So we are going to study that in next session. So anyway, today we'll stop here. Hope you enjoyed the lecture. And so thank you very much. Have a nice day. If you have any question, please put them on forum. Okay. Sure. Bye.